Right, welcome back, folks. In today's class, I'll talk about the mechanical energy on an isolated system. So, just want to tell you what isolated system is all about, and then we will solve some problems based on that. So isolated system is in which no energy is being transferred into the system and no energy is being taken out of the system. System means this is defined by a boundary. So for example, if there is a object placed on this cliff and you throw it like this, and let's say if I assume it that it is an isolated system, so it means whatever the mechanical energy while it launches from here or when it reaches on top or whether it's coming down or whether it reaches or about to reach on the ground, the mechanical energy of the system will remains constant. So at location 1, location 2, location 3, and location 4, mechanical energy will be constant. So that's the concept of isolated system. So let's dive onto a problem based on to the mechanical energy of an isolated system. So a human cannonball in the circus is shot with the speed of 21 meters per second at an angle of 20 above the horizontal platform, and the platform from a platform that is 15 meter above the ground. So there is a platform which is above the ground, and then the acrobat has a mass of 56 kg. He moves like this, and then he lands the onto this section, and which is 2 meters 2 meters above the ground, 2 meters above the ground. So he starts from this location. Let me change the color. So this he starts from this location, then reaches here, then comes down and then lands at this point onto this location on this net, which is 2 meter above the ground. Now I wanted to find out it, what is the gravitational potential energy relative to the ground when he is at the highest point of the flight. So that's what we wanted to find out. What is his gravitational potential energy? Gravitational potential energy. That's what we are looking for. And then also says that uh, the fly ignore the effects of air resistance. So we don't need to consider any kind of a resistance. It means there are no losses. What does that mean also? That the mechanical energy remains constant if there are no losses. Okay, so this is a question of isolated system. Now, first of all, I'll try to find it the mechanical energy at location 1. So mechanical energy at location 1 will be equal to he's launched at a speed of 21 meters per second, so there is some kinetic energy. And then let's say what's the potential energy is. Potential energy mgh plus half mv square. Mass value is 56 times 9.81 times uh, he is launched from a height of 15 meters. So 15 plus half times mass is 56 multiplied with v square, which is 21, and this will be square. And then there is also angle provided to us, but we're not going to consider that angle. We're going to consider the whole velocity. Now if I do the math, this should come out to be 56 multiplied by 9.81 multiplied by 15. This value is 8240.4 plus 21 square, and multiply by 56 divided by 2, that is 12,348. This number plus 8240.4, that is 20,588.4. That is the mechanical energy when it is launched at location 1. Mechanical energy at location 1. Now this mechanical energy will remain constant throughout. So let me do the calculation one more time. Just want to make sure that I am doing all the calculations right. So he's launched 21 meters per second. So 21 multiplied by 21 and then multiplied by 56 divided by 2. that is this much, and then 56 multiplied by 9.81 multiplied by 15, that is 8,240 plus 12,348. Yeah, that is 20,588 joules. Now, what we're gonna do is we'll try and find out his gravitational potential energy. So this is what we are looking for, the potential energy. That's what we are looking for. And I want to ask you guys a simple question that think about this, pause for a second and think about this. What is the kinetic energy I'll consider here? So when we were at location 1, the object was moving up, object was moving forward also. Here, object was moving up, moving forward also. But when it reaches on top, as the word says, top, so can the object move uh, any further up? If if it says top, but it can move in the forward direction, but I guess you got guessed it right, it cannot move towards the top direction. So I have to consider only the horizontal component of this velocity. That will be 21 cos of 20 degrees. So I have to consider Vx. So I'm gonna do the calculations for that. So 21 cos of 20, that will be 19.73 meters per second. Now, that is the velocity on top. And now I will try and find out the potential energy. How I'm going to find out? The mechanical energy will be the same. Mechanical energy at location 2 is same as mechanical energy at location 1. L2 equal to potential plus kinetic, and potential is what we're looking for. Kinetic is half mv square. Mechanical is what we figured out, 25884, 25888.4, and then this is equal to potential energy plus half times mass is 56 multiplied by velocity will be 19.19.73 squared. And let's do the calculation for the mechanical energy, kinetic energy on top first. So 56 multiplied by 19.73 multiplied by 19.73 divided by 2, that will be 10,899.64. Down here it is 25,658.8. Oops, should write 588.4 plus potential energy. This is going to go on the other side and we'll subtract it. Again, I'll do the calculation one more time so that to make sure that I'm not making any mistake. Multiply by 56 divided by 2. Yeah, awesome. Minus 20588.4. That'll come out to be 9688.7 joules. That is, oops, I should write an equal sign here. That is equal to the potential energy. Now, this potential energy which we've got, we can we can also find the height from the ground if I wanted to. So we figured out the answer. What is the potential energy? Let's say if the question says find the height, then you will write mgh, and then you can also find the height. So I'm not going to do it right now, but hopefully you understood the question. Mass is 56, this is 9.81, and you can find the height from here also, that what is the height with respect to the ground. And then if I then the final part, if I were to ask to find out the how fast he is traveling, that's what I've been asked. So here, what is his speed when he is about to land onto this net? So as I said, mechanical energy will still be the same, and that will be 20,000. 588.4, and I need to find out the kinetic energy at this point. So to find out the kinetic energy, I'll again rewrite the equation. Mechanical energy is equal to potential plus kinetic energy, and then mechanical energy is, as I said, it is given to me 28 20 20,588 8.4. Potential energy, it is at a height of 2 meters. This is at a height of 2 meters from the ground. So this will be mgh. So 56 times 9.81 times 2 plus we are asked to find what the what how fast he is traveling. So velocity is what we are asked, not the kinetic energy. So half mv square, and then we will do this question. So 56 times 9.81 times 2, that is 1098.72, and this is 2588.4 plus half 56 times v square, and 2588.4 minus 1098.72, that will be 19,489.68. Half times 56, you can reduce it to 27. So 27, uh, or let's say 56 divided by, I don't want to make a mistake, 28, not 27. This is 28 v square, and dividing both sides by 28 cancels out. So 19,489.68 divided by 28, that will be 696.06 equal to v square. And then I will square root this number. That will be 26.4 approximately meters per second. That is the speed with which he will land on the ground. So hopefully you understood how we're gonna approach this question. And next video I'll try and solve another question. Until then, goodbye.